Okay, yes, I'm Micaiah. I'm going to be talking about Surfpool today. Yeah, let's get into it. Our goal at TXTX is to build the best developer experience of any chain. And we're doing that with Surfpool. So Surfpool is, on the surface, a massive upgrade of the Solana test validator. But then under the hood, it is introducing what we're calling infrastructure as code to Web3. So we're going to talk first about the simulation parts of this. So whenever you are deploying something, you need to simulate it. You want to test your program thoroughly. And there's a few options that you have for that. And the first is LocalNet. So when you go to LocalNet, local environment, it's really easy to start a network, kill the network. But the problem with it is your program is not built in a vacuum, right? I'm going to move to the other side to not have this noise. There we go. Yeah, the network lives locally only, and your program's not built in a vacuum, right? You need additional infrastructure. You might need token programs like USDC. You might need something like Pyth or Drift that your protocol relies on. And so the biggest strength of LocalNet, that it's this clean room that's easy to spin up and tear down, is also its biggest weakness, right? The other option you have is DevNet. So when you're deploying to DevNet, it's free, public staging environment, collaboration friendly. It's a decentralized network, and you can connect your wallet to it. So you have this environment where you can do end-to-end simulations pretty effectively. But once again, your program's not built in an environment and built in a vacuum. And if it needs to interact with the rest of the world, will it be on DevNet? Every team uses DevNet differently. Some people, it's a clean staging environment. For some people, the programs that they deploy there might break or change or just be removed completely. So if your program depends on one of those, DevNet is not a particularly effective place to be testing. Then you have mainnet. So, all right. Yeah, deploying to mainnet is kind of the gold standard, right? That's the best place you can be testing your protocol. The problem is it's scary and it costs money and mistakes are expensive, right? And so because of this, teams usually wait until late in the development cycle to go to mainnet. So if mainnet testing is the gold standard, the question is, how can we enable developers to have that mainnet-like confidence without the costs or the risk or the friction, and have that as early as possible? And that's where Surfpool comes in. So Surfpool is your LocalNet experience, really easy to spin up and tear down with mainnet data. So it runs locally just like the Solana test validator, but it can boot up instantly on a Raspberry Pi, and the data that you need from mainnet will be present when you need it. So you keep the speed and control of LocalNet with the realism of mainnet in your testing. So as I mentioned earlier, we want Surfpool to be the best first experience for any developer. And I think a lot of developers, when they first decide to build on Solana, one of the reasons is because it's fast, right? And so we want that same experience to be had in Surfpool. So when you start Surfpool, it will automatically deploy your protocol for you. You can see almost 300 transactions processed in a matter of seconds. We've built this terminal UI that's also, it's not just fast, it's didactic. Like it kind of gives an intro to some new concepts to Solana devs, slots and epics, the things that when you're first starting development on Solana might be new. It's introducing some of those concepts. Yep, and Surfpool, it's giving you control over your chain, stopping and starting block production. It also immediately fetches mainnet data for you right when you need it. So if you make a request to your Surfpool instance, it's going to match exactly what is on mainnet. So having unlimited access to mainnet data is one thing, but we also have introduced these cheat codes that allow you to bend the consensus rules of your chain. So those cheat codes go along with Surfpool Studio. This is a locally hosted web UI. It gives you a clean interface for all these features. And so Surfpool Studio has a lot of features like stopping and starting block production. You can change you can time travel on your chain. So this sort of thing makes time-based testing really easy to do. It also has a built-in faucet. So faucets are a pain on DevNet. You don't know if you're going to be rate limited. It can be really difficult to get enough SOL for what you need. And that's just for SOL. If you need tokens, you need USDC, you need Juke or something like that. You have to be able to interact with those protocols. It's a pain. Right here in the Surfpool Studio, you have a SOL and any token account faucet. So it makes getting everything you need to test your protocol super easy. And then another thing that's built into Surfpool Studio is a transaction inspector. And this inspector, because of the profiling we can do on your transactions, is not just giving you transaction level insights, but instruction level insights. So here we have an account state diff before and after each instruction. So you can really see what every instruction that you're calling is doing, as well as CU usage for your instructions. And then as a cherry on top, we've launched SurfNet as a service. So whenever you're collaborating with your team, or maybe you are going to an open beta and you need a place to have like a hosted network like DevNet, no friction, you single command in the CLI and you're ready to collaborate. So those are the features we've got on the simulation side. But then there's this other side that Web3 has some deeper issues that we've been obsessed with fixing. And so, deployments and operations is something that Web3 is not mastering at this point, right? Like if we compare the level of maturity of Web2 cloud infrastructure with Web3 infrastructure, which is supposed to be the future of money infrastructure, right? It feels like we're stuck in the 90s. People are managing their operations with just like one-off JS files or bash scripts. And we've lost billions of dollars due to DevSecOps hiccups and compromised private keys, which is a huge problem. We think we've got the right foundation to help solve this problem for Web3 by introducing what's a best practice in Web2, which is infrastructure as code. We're introducing that to Web3. So let's dive into these design principles and define what we mean by infrastructure. So we've identified three big categories. There's on-chain infrastructure. So by that we mean all the transactions needed to deploy your protocol, but that includes there's initializing and setup instructions that need to be called to your protocol to get it set up. Then second, you have your signing infrastructure. What needs to be signed, by who, by what key? How can we enable developers to have low friction, fast signing locally, but have secure multi-sig schemes when they're going to mainnet? And then third, we have the off-chain infrastructure. These are all the components that your protocol requires that are off-chain. Indexers, watchdogs, scheduled jobs, sentinels. These components need to be testable locally, but also able to run at scale on mainnet. So it needs to be tightly coupled to your deployments. And then we've got the code part of infrastructure as code. So Web3 infrastructure is very sensitive since it involves key pairs, potentially controlling millions of dollars of on-chain assets. The code component needs some constraints, right? So we wanted a declarative language that it's easy to see what's happening without executing any code. And so for this, we went with a non-Turing complete subset of HCL, and we're calling these Web3 runbooks. So these runbooks are essentially, you're describing a workflow of transactions. And so we do a simple static analysis of these runbooks, and we create a direct acyclic graph. And what this enables is kind of cool is we have these stateful executions. So if you execute this runbook, you do some actions on chain, and then you execute it again. If your inputs haven't changed, nothing in the graph has changed, then your runbook is a no-op. We don't actually do anything on chain for you, so you're not wasting those funds. But if you change one node in the graph, we can execute just those things downstream in the graph. And so what this is enabling is live, die, repeat. Right? Your goal in testing is to fail often and fail fast, and so that you can discover early all the weak points in your protocol. Just discover every flaw. And so iterating quickly is what we want to enable devs to do. And then when you're ready to go to mainnet, all the kinks have been worked out. You've been through it 1,000 times. You've done your exact deployment flow that you're going to do on mainnet. You've done it 1,000 times locally, so you have some confidence in it, right? And so how does this work practically? When you start Surfpool, we can detect if you're in a Pinocchio-based or Anchor-based project. When that's the case, we're going to scaffold for you your infrastructure as code. So after you review and validate it, it's going to have those three constructs we touched on. The actual program that's being deployed as part of your infrastructure as code. Then you have the signing infrastructure with a way to upgrade and change the signing method depending on the network you're targeting. And then there's the off-chain infrastructure, which we'll touch on soon. Also, if you start Surfpool with the watch flag, --watch, and you recompile your program, it's just going to automatically redeploy it for you. And so you have this really quick feedback loop in your development lifecycle. You test, make changes to your code, rebuild, it redeploys, test again, you just iterate again and again, right? Let's look at the off-chain directives. We're excited about this one. So in this specific program, we are emitting a CPI event. This Surfpool can detect these kinds of patterns in your transactions and generate a construct that's going to process the on-chain data and create what's called a subgraph, an index of your program. And we can index these events, any PDA accounts your program creates, any token accounts your program references. So this indexing engine is ingesting your data from the SurfNet activity and exposing you just a simple GraphQL API, right? So it makes accessing your program's data super simple. None of the details are lost. Even like the GraphQL spec has your Rust docs embedded in it. And so transactions are emitted, the events are indexed in real time, added to this database. And so you can build your front end very easily. And when you go to mainnet, you have the exact same schema. You have the exact same database. You just change the backend URL and you're ready to go to production. Okay, last but not least, the signing infrastructure. We're almost done here. The first checks that TXTX received last July came from a company that lost millions due to compromised private keys. So security is something that is in our DNA, and we believe we've designed the right framework to help teams. So to be able to iterate locally on an ephemeral key pair, but then also have a safer signing setup on mainnet. So Today, we support 3 types of signers: hard-coded key pairs, connected web wallets, and multi-sig setups. Switching between them is just a few lines of config. And then these runbooks support 2 execution modes. So we have unsupervised execution, which runs like any CLI script. So you type in the command and it's just going to execute, right? The second is called supervised execution. So we are hosting for you a little local only web UI where it takes you through all of your connected wallets, every single transaction that you're executing. We think this supervised mode is a perfect guardrail because it gives you insight into everything you're signing and gives you transparency in your deployment and operation flows. And that was the same runbook, just different execution mode. But then whenever you're ready to upgrade to a different type of signer, you just change it to a web wallet, and that same UI, it's going to prompt you to sign everything in the browser at the right time. So it's just a few lines of config to upgrade to more secure signing schemas. It's the same thing, just a few lines of config to go from a web wallet to a squad multi-sig signer. So yeah, we've talked about the simulator. But within a project, Surfpool quickly becomes a way, just a force multiplier for velocity and security. Just wrapping up here, we think the fastest chain should have the fastest and best tooling. We're supporting builders already, so please use Surfpool, start the repo, clone it, test it, break it, open issues. If you're interested in using the backend as a service, please reach out to me. And thank you to the OnlyDevs team for